Hello everyone, this is Dhanlakshmi, Assistant Professor from RMT Engineering College of Technical Department. In this session, I would like to discuss about the RS232 standard, right? And the subject embedded systems, where in Unit 2, we were discussing about ports, buses, protocols, communication protocols. So in that, one of the serial communication protocol is our RS232 standard. So in this session, I would like to discuss about RS232 standard. So before proceeding with RS232 standard, first let us have a recall let us have a recall of what is a duplex, half duplex, simplex about, right? So connection, when we go for a connection, that we have a simplex connection, then we have half duplex and full duplex. So simplex was the one where it is a one-way communication. It can communicate in only one direction. Whereas in the half, for example, we can say our printer connected to a PC or a mouse or a keyboard, all these are going to be a one-way communication where the data will be flowing only in one direction. Whereas in case of half duplex communication, the data can flow in both the direction, but not simultaneously. At a time, the data cannot flow in both the directions. So that is called as half duplex communication. Or like when talking on a radio, like right. And whereas a full duplex connection is something where the data can flow in both the directions simultaneously at a time. So telephonic communication. So that's called as a full duplex communication. So this is the difference between simplex, half duplex, and full duplex. Right. And transmission rate, we will be used to represent our transmission rate in terms of bits per second, BPS. Right. And it is in kilobits per second, kbps or mbps. Right. So we'll go to the serial communication protocol, and for today's session, session of discussion, and let me take RS232 standard. You are all very familiar with RS232 standard, so still we'll try to get some other. We'll try to get a few more points regarding this RS232 standard. So we have RS232, then RS422, and RS485. So let me go for the RS232C standard. That is, RS stands for recommended standard. 232 is a number and C is the latest version. So when we take RS232, it's a serial communication protocol. So where you have RS232 connector, DB connector, along with that a MAX 232 IC and the MAX 232 IC and the connector altogether, we'll have, we are saying that as a RS232 connector, right? And the RS232 standard, right? It's a communication protocol. So where you can see it is used for many purposes like connecting to a mouse, printer, modem, and industrial instrumentation. Where RS232 is a limited point-to-point connection. We'll discuss these things in detail in the forthcoming slides. So where RS232 is a limited point-to-point connection between a PC and a device, right? And hardware, you can see that RS232 can be used for serial communication up to distances of 50 feet, right? So, and it's an asynchronous communication between two serial links on a network between a data DTE and DCE. DTE is for data terminal equipment and DC is a data communication equipment, right? So, and you can see the DB connector here, that is RS232 connector. RS232 connector is a DB 9-point connector, where you can see the 9 points given here, and we have a DB 25-point connector also, right? And the DB 9-point connector, you can see the first pin will be for data carrier detect, then second pin for receive data, and third pin for transmitter data, fourth pin for data terminal ready, and fifth pin for ground, and sixth for DSR, data set ready, and 7 for request to send, and 8 for clear to send, and 9 for ring indicator. So these are the pin function, pin description of this DB 9-point connector. Right? And as I told you, DT is a communication between DT, data terminal equipment, and data communication equipment. So where you can see that it's a connect, you can see the handshaking signal, 9-point pin connector. How it is doing the handshaking signals. You can see this is our UART form, that is which we have in the PC, and this is the external device we have DCE, right? Data terminal equipment and data communication equipment. How these are sharing the data, how these are going to communicate it with help of this handshaking signals. So here you can see the transmitting pin, and for the other one it will be a receiving pin, and this will transmit, this will receive, and the same way this will transmit, the other one will receive. Here we have data carrier detect point or detect pin, and DSR for data set ready, DTR for data terminal ready, right? RTS for request to send, and CTS for clear to send. So this is how it will communicate. And first of all, we should understand why we are going for RS232 standard, right? So as usual, as we know that in the embedded board or MCU unit, where you will have a UART, right? UART, universal asynchronous receiver transmitter, right? So which will be in the TTL logic or transistor logic, which is in the TTL standard. When we go for a TTL standard, the signals will be in the level of 0. That is for zeros, it will be in the 0 volt, and for 1, it will be in the 5 volt range, right? So that is our TTL standard. So as such, you cannot send these signals when you communicate externally, right? When you communicate for a remote communication, this is not preferable because the signal will get corrupted by the noise. Right. So that's why we go for RS232 standard, where what we're doing in RS232 standard, what we're doing is we are converting the signal level, which means that for all, you can see that for all logic 1, the signal is converted in the level of voltage level of -3 to -25 volt. Similarly, the logic 0, for all logic zeros, it will be converted, the voltage level will be converted for +3 to +25 volt. Right. So this is what this RS232, that is max 232 IC is going to do. It is going to do this conversion, signal level conversion. Right. For TTL standard, the voltage, the signal level will be of 0 volt to 5 volt, and you cannot send the signal as such because the signal will get corrupted through the noise. Right. So therefore, what we do is we are doing the conversion with the help of RS232. Right. So that is this max 232 IC will do the conversion, or where it will do the conversion for all logic 1 to be -3 to -25 and all logic 0 to be +3 to +25. So this will be transmitted at this end. The same thing will happen at the receiving end also. The receiver end will be receiving the signal. Again, it has to do the conversion back to 0 to 5 volt, right? So that when we send the signal of this level, the signal can prevent the noise. You can go for the lower noise reduction. Right. So that's why we go for RS232. Here you can see that RS232 DB connector, RS232 connector, and this is our max 232 IC. Right. This IC is going to do the conversion. So here you can see, and let me once again, let me take a pen here. So you can see that either from the CMOS, the logic, what we call as CMOS logic or the TTL logic, right? This TTL standard, where from TTL standard, the signals will be in the range of 5 volt or 0 to 5 volt, right? And where these signals are converted, at the RS232 output will be in the range of, that is for all zeros, it will be converting to +3 volt, all zeros, it will be converting to -3 volt to -25 volt, and all logic ones will be converted to all logic ones will be converted to -3 to -25, and all logic zeros will be converted to +3 volt to +25. Right. So after doing this conversion, the output signal is sent. So that's why we say it is RS232 output. So the signal level, what we are getting from TTL will be in the range of 0 to 5 volt, right? This signal level is now converted to -3 to -25 for one logics and +3 to +25 for logic zeros, right? So this will be transmitted. At the end, you can see that RS232 output, the signal level has been converted and these signals have been transmitted, right? And similarly, on the receiver side, this is the transmitted end, where in the receiver side, again, we will be receiving the signal at the RS232 standard, right? Which is in the range of -3 to -25 and +3 to +25. Again, this has to be converted back to 0 TTL logic, right? So TTL logic, again, as we know, the TTL or CMOS logic, where we have to again convert back to 0 to 5 volt. So that conversion will be done with the help of this max 232 IC. Yeah. So on the when we want to transmit, we have to convert that to RS232 standard. Similarly, when we receiving also, when at the receiver end, it will receive only in the RS232 standard, right? Again, that has to be converted to TTL or CMOS logic. That is 0 to 5 volt, right? So this is how the conversion is done. So you can see that. Right. So this is what the conversion is done. Here you can see. So the MCU unit, where it will be sending it from the MCU unit, the signal will be transmitted to the max IC. Okay, let me take the pen again. So you can see that from MCU microcontroller unit, the signal has been transmitted to the max 230 IC, max 232 IC, that is RS232 standard IC, where this signal level at the microcontroller unit will be in the TTL standard, right? TTL standard, which is of 0 to 5 volt. Now this signal, which has to be converted to RS232 standard, which means that it is going to convert that 50 to 5 volt to -3 to -25 or +3 to +25 based on the logic, either logic 1 or logic 0, based on that it will do the conversion. After converting, those signals will be transmitted by the pin 13 and 14. So the signals will be received and transmitted to the microcontroller using the pin 11 and 12, right? So these are the pins through which the converted signal will be transmitted to the DB connector. You can see that after converting it to RS232 standard, you can see that the pins 2, 13 and 14 is sending the signal to the RS232 connector, DB point connector, DB9 point connector, where the signal is sent to the connector. And from the connector, the signal will be transmitted. Similarly, on the receiver end, when it receives the signal through the connector, again, it will be given to the MAX 232 IC, where it will convert back again that RS232 standard to TTL standard, right? So again, that converted TTL standard signal will be given to the MC. So this is how it works. So this is one of our serial communication protocol. Right? And yes, and we should know the difference between RS232 standard and RS422 and 485. So let me come back to the slide later. This is the comparison between RS232, RS422 and RS485. So in this case, this RS232 is a single-ended where we have a B plus point and the ground. It is the signal between the ground and the B plus, right? Whereas in case of RS422 and 485, it is having a different concept called differential signaling. Differential signaling in a sense where the signals are sensed between B plus and B minus. So we are always sensing the difference between B plus and B minus. So therefore, whichever signal is common to both B plus terminal and B minus terminal will get cancelled. So therefore, we are still going for more low noise reduction. So that's why that is the difference between the differential concept between the single-ended, right? So instead of going for single-ended, if we go for differential signaling, where we can still have a low noise reduction, right? So that is one thing, that is one point. And the other point is our maximum distance here we can have in the RS232 is 15 meters, whereas in case of RS422 and 485, it is up to 1200 meters here, right? And then in case of RS232, it's a full duplex, whereas in case of RS422 and 485, it is half duplex. We have already discussed about what is half duplex and full duplex, right? Then here we can see that here it is a single point to point, which means that it is a one driver and one receiver concept, whereas here it's a multi-drop in the sense here we can see that one driver and 10 receivers, right? So where one master will be communicating with the 10 slave devices. That is multi-drop, where here the signal can always be flow from the driver to receiver, and all the slaves cannot respond back. That is the drawback we have in multi-drop pointing, right? Whereas you can, whereas the standard what the network topology what we have in RS485 is multi-point, where it is having, you can see the 32 drivers and 32 receivers. So therefore, they can come, even the slaves can communicate in both the ways. The both way communication is possible, right? So 32 drivers will be communicating with 32 receivers. So therefore, here it is multi-drop, whereas here it is a multi-point. And you can see that the low noise reduction can also be achieved with the help of a twisting of cables. That is what shown in this. Right, that's what's shown in this previous slide, where when we go for twisting of cables, we can have still more noise reduction. So you can see that in case of RS232, the cable slate is of state cable, whereas here you can see that in RS422 and 485, the cables are twisted. So when we go for twisted cables, when we go for twisted cables, another advantage of going for twisted cables is you can see that the noise currents, the induced noise currents, these bold arrows, right? These bold arrows are our noise currents, which is induced due to this magnetic field, right? Due to this perpendicular magnetic field, we have the induced noise currents like this. When we have a state cable, these noise currents will be cumulative. They will accumulate, right? So they are, that is one point, that's just one disadvantage we have in the state cables. Whereas when you make the cables to be twisted pair cable, when you have a twisted pair cable, so when you twist at each and every twist, you can see that the noise currents will get cancel each other, right? So the noise currents will get cancel each other at every twist. So therefore, they both will cancel each other. That's you're still reducing the noise. So we can go for low noise reduction, right? So low noise reduction can be done with the help of twisted cable as well as the differential concept. So differential, when you go for differential signaling, that also will reduce the that also will reduce the noise. So that is why due to this twisting pair of cables and the signaling, right, and the differential signaling, we are having more advantages when compared to RS232. So RS485 and 422 will be having these features which will make more advantages when compared to RS232. So this is all about the difference between RS232, 422 and 485. Right, thank you. Thank you so much.